What's up, math fans? Today I want to talk about rationalizing a denominator. And what that means is if you have an irrational number in the denominator of a fraction, it's not okay. Here's what I mean. Let's look at square root of 25, right? You see radical 25. That means what are the factors of 25? What times itself gives you 25? Hopefully you know that the square root of 25 is 5. So in order to understand this video, have a calculator available and also just understand how to factor, especially the perfect squares. Know your perfect squares. So 25 is a perfect square, therefore radical 25 is 5. That's known as a rational number. A rational number is a number, look at that word ratio. A rational number is a number that can form a ratio, can be represented as a fraction. So 5 I can put over 1, 5 over 1, and it's rational, all right? You don't have to put it over 1, you know it's over 1. Look at radical 7. What's the square root of 7? Type it in the calculator. You should get some weird decimal, something like 2.6 blah 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 blah. It's a decimal that fills up your whole screen, and if you had a bigger calculator, it would fill up the whole screen there because it is a non-terminating, non-repeating decimal, and that makes it irrational. Irrational is non-terminating, non-repeating, but you knew that already. So, my point is, if you see a fraction where there's an irrational number in the denominator, that's not okay. Mathematicians have decided we would much rather see the irrational number in the numerator. That's okay, but not in the denominator. If we see it in the denominator, we must rationalize the fraction or rationalize the denominator. All right? And here's how. Of course, you can get an idea of the value here by cheating. You just run to the calculator and press 1 divided by parentheses. I think radical 7 might give you another parentheses depending on your calculator. So you have to close parentheses. You might have to close parentheses twice. And you could get a crazy decimal irrational answer. But mathematicians don't want that. We want just the fraction itself. So running to the calculator and getting a crazy decimal is not what we want. Here's what we want. All we want to do is somehow get that irrational out of the denominator, and you'll see that it will generally go into the numerator. But how? What are you allowed to do fractions? What are you allowed to do to fractions? Anything you want as long as you do it to top and bottom. When I say anything you want, I mean you get to multiply by 1, because multiplying anything by 1 doesn't change the value. So I'm going to multiply this by 1, but you never write it as 1, that's boring. So you write it as 1 over 1, same in top, same on the bottom. You can write it as 2 over 2, you can write it as 10 over 10. I need to write it as something over itself that's going to magically turn this radical 7 into a rational number. And check this out. You see radical 7, or any radical you want, if you take a radical, I'll stick with 7, and you multiply by itself, guess what happens? You're allowed to multiply the radicands, making this radical 49. And what's the square root of 49? 7. So what happens when you multiply a radical by itself is the number that was inside ends up coming outside. And I'm no longer going to need to show that middle step. So if I want this to become rational, I just multiply by radical 7 over radical 7. Whatever you do to the bottom, you do to the top. 1 times radical 7, you can multiply, technically you multiply the coefficient, don't multiply by the radicand. So you're not doing 1 times 7, you're doing actually 1 times the 1 outside. So you're going to get 1 radical 7 over radical 49, which is 7. Look at that, I have a rational number on the bottom, irrational on top is okay with me, and that is equivalent to how it was originally. What is equivalent? What is an equivalent way I can write this fraction? 3x over radical 10. Same thing. If I want this radical 10 to go away, radical 10 over radical 10, that's not going to change the value. It's just going to be able to be rewritten with an equivalent fraction. So let's handle the bottom first. Radical 10 times radical 10 is radical 100. The square root of 100 is, you guessed it, the number that was inside, 10. Now, remember what I said, you're not multiplying this times this, you're not doing 3 times 10, because 1 is a coefficient, 1 is a radicand. So you're doing 3x times the one that's outside, and that's still 3x. and then the radical 10 stays. So my final answer is 3x radical 10 over 10. You do not cross out the 10s. One's inside, one's outside. Not allowed to cross them out. That's my final answer. If maybe that 3 was a 10, then you can cross out those 10s. Outside and outside is fine, but not inside, outside. All right, here's one complicated one. Let's say 2 over 4 plus radical 3. How could I possibly rationalize the denominator when there's a whole number and a radical, or a sum of a whole number and a radical? Well, you do something called a conjugate. If you've been learning multiplying conjugates, remember FOIL? I'm going to multiply by 4 minus radical 3 over 4 minus radical 3. Check this out. Top is easy, distributive property. That's 8 minus 2 radical 3 over, now we're going to do FOIL. If it helps you, I'll put that in parentheses. So I got to do 4 times 4, 4 radical 3, 4 radical 3 again, and then radical 3 here. Be careful with the signs. So I got 16, 4 times 4 is 16, 4 times negative radical 3 is negative 4 radical 3, positive 4 radical 3 from the inner, positive 4 radical 3. And then radical 3 times negative radical 3 is negative radical 9. And you'll see why that's perfect, the same reason it was perfect up here. It's going to cancel out. So I'm going to get 8 minus 2 radical 3 over, what happens here? Oh, what happens when you multiply conjugates? The two middle terms cancel out. That cleans up nicely. So now I have 16 minus the square root of 9. You know the square root of 9 is a perfect square. We set it up like that on purpose to be a perfect square, just like we did earlier. Square root of 9 is 3. 16 minus 3 is 13. And there is your rationalized denominator, so you have an equivalent fraction. All right? So if it's a monomial, you multiply by itself. If it's a binomial, you multiply by the conjugate. Hope you can see that. Thanks for watching. See ya.